Good morning, everyone. Bright and early. If you don't have your video on, you need to turn your video on, please. Got just a few more people. I'm going to give them a couple more minutes to get signed on. And just so you are aware, class meetings are recorded in case someone is absent so that I can post whatever we're going over in class. So you need to be aware that classes are recorded for that reason. Anyone have any questions as we're waiting for everyone to get connected? Have you done an online class before, some of you? Yes? Okay, so this won't be too new for you then, all right? Have you used Teams before, some of you, or have you used Zoom? Not Teams, okay? One of the reasons that we're using Teams is because it doesn't time out on us. So that's one of the reasons that we're using Teams. You know, if you don't have a particular version of Zoom, it only allows you to have class for so long of time before it times out. Team does not do that. So that's one of the reasons that we're using the Teams. Another reason is because it's free for you to use our school computers. So there's two reasons. We don't have to make a purchase with the Zoom that way since we already have the Teams. There are some features that we can use in Teams that utilize Office back and forth that we'll be able to share information with. So that's a third reason to utilize the Teams. So for those of you who may have had trouble getting it downloaded on your computers, if you're just using the web browser today to connect, be sure that you go by the tech help and get that downloaded on your computers so that you can use the other features that we'll have available during class later on. We won't use the features all the time, but you want to be able to access them when it's needed. And you can only do that by having the app downloaded, not through the web browser. All right, just a little housekeeping information. I just want to remind you that I have sent out invitations for the Remind app to place on your phones, and that way I can contact you quickly if something changes about class, especially with this 8 o'clock class. If something comes up that we can't have the class, I can text you that way and you'll get that message very quickly to know about class, or if a sudden change comes up, you can get that information. If you're sick, you can text me back through that Remind app and I'll know very quickly before class starts if you're having an illness or something and can't be in class. So it's a good way for quick communication back and forth. I don't send a lot of information back and forth on Remind. I just kind of use it for reminders and quick information back and forth. But I would like you to please sign up for that so I can get that information to you quickly. Secondly, I've sent information out about signing up for the Google Classroom. Again, I use that to share PowerPoints. Sometimes they do not load on Brightspace well, and this way you'll have access to the PowerPoints that we have in class by using them through Google Classroom. So that's the reason for signing up for the Google Classroom. So if you haven't taken care of that, that's another option that you need to be sure you're taking care of in the next day or so. Hope that you've signed in on Brightspace as well and taken a look at the materials that have been posted under the Getting Started. All of that information under the Getting Started is like a class orientation to things that you should know about the class. And you have a syllabus quiz. It's called a syllabus quiz, but it's really a class orientation quiz. It includes information that's on the syllabus and all of those items under the Getting Started menu on Brightspace. And all of those items are kind of included in that quiz that you will take. That quiz is due tonight by midnight. It's a 30-question quiz that you have to take. So if you haven't seen that, just be sure that you get that taken care of as well. So that's your first assignment for a grade, is to do that quiz. That is on Brightspace. Any questions so far? Okay, so just kind of summarizing things that, you know, housekeeping things that you need to make sure that you take care of. As far as the technology, be sure if you haven't done it already that you do get the Office 365 with the Teams app, download it to your computer. And if you're having trouble with that, you have to go through the tech help people there at Bassett Hall on campus. Your textbook, I'm not going to require you to get that textbook, but you might can find some used ones from people who had them for last term. So you might could get that cheap if you get that from someone who had the class last term. You could go together and share a book with someone. Most of what the book is a very good resource for studying. We go over and highlight topics within the book, but by reading the sections in the book, it will reinforce topics that we go over in class. We occasionally have homework out of the book, but not always. And by not requiring you to have the textbook, I will not assign as much homework from the textbook that way. You will need a calculator. So if you don't have a calculator, you will need to get a calculator. I prefer the TI 8384 calculator. If you have one, that one will be great. If you don't have one, don't run out and buy one because it's expensive unless you're aiming to take additional heavy-duty math classes. Otherwise, just get a TI 30 calculator, which is like 20 bucks. So it will work. It will suffice for what we need to do. Okay. I just want to remind you that you should check Brightspace daily for assignments, even though we may not be in class, because we have so many hours that we have to account for in the short term. You will have assignments that are outside of class days. So they will be posted not only on class days, but outside of class days. So you need to be sure that you watch Brightspace for when assignments are posted. So some days will be outside of class days when they are posted and are due. So be sure you're watching that. I just want to emphasize that when you're using Brightspace, it will show up maybe a date that an object is open versus due. And I will give you a due date for an assignment, but it may stay open on Brightspace, and that date is not a due date. So don't let that confuse you. That date that's showing on Brightspace is how long it is available, not necessarily the due date. So you need to be sure you know the due date of assignments, not what it's showing on Brightspace. There may be a difference. So be sure you know the difference in what you need to do, because there is a penalty if your work is late. Just because the assignment is left open doesn't mean that that was the due date. So be sure you know the difference there. Also, be sure you read the absentee information very carefully, that you know the information regarding absentees. Absentee is part of your grade. So being in class and taking care of assignments will contribute to your grade, just being in class. So hopefully some of you have read that information already, and that's just kind of hitting the highlights of what you'll go over as you read the getting started information. But those are kind of the key points that I want to be sure that you do know. Anybody have any questions about any of that information? I just kind of briefly skimmed over that information. All right, we're going to start with our first lesson. So our topic is, in our first unit, is sets. I'm going to switch to a different screen. Can everyone see that screen? If someone could answer me yes or no, you can see this screen with a blank piece of paper. Yeah. Yes, you can. Yes, you can see it?
Yes.
All right, thank you. All right. So our first lesson starts our first unit, which the topic is sets. And sets is just a method to collect information, to organize information, to sort information. So we have a method to sort and classify objects into well-defined collections. All right. Now, some keywords there are well-defined and the collections. Those are two components that are important in terms of representing sets. The well-defined part that just means that it has to be unique. It has to be easily identified. And it has to be distinguishable. You have to be able to tell it apart from something else. So, for example, if we were talking about Man, my mind went blank there. If we were talking about people in a classroom. Versus people with jackets on in a classroom. Which of those, one or two, gives you a better defined set? One or two? Who can answer that?
Two.
Two. So when we're talking about sets, we want to think about what makes it well defined, and we want to look at being able to distinguish information one from another. The second component of that is the collection or the membership. The collection would be the membership. So we would also want to be able to establish, I can't spell this morning, I can't think this morning. You want to be able to establish membership easily within that group. And when we talk about membership, we use this term called element. So that's a definition or a term that we need to know, which just means that we are a member of a set. And we use the symbol of this funny looking E when we say something is a member of a set. So we have the term sets. That's what our entire unit is about, which is a method to collect objects. We want this set to be well defined, and we want it to be a collection of things. When we talk about something being well defined, we want to be able to distinguish it from something else, a different kind of group. We want the membership to be established, that you are a member or not a member. And if you are a member, we can also call you an element. You are a member of that set, and we can use the symbol to say you are a member of that set. So if we had set A and had these elements, A, B, C, we could say the element A is a member of set A. Notice we have a lowercase a for the element. The capital letter A is the name of the set. Notice we also use these little braces around the set, not parentheses, not brackets. We have to use these little braces when we are using sets. It does make a difference in the notations that you're using. We got that? Good to go so far. Okay, the next step is how to express sets. We have three ways. We can use a roster, which just means you're making a list. We can express them verbally, which means you write them out in words. And we use set notation. That's an O there. Set notation. Now your textbook actually calls this set builder notation. So you will hear that term sometimes used by other people, other textbooks. It does mean the same thing. Set notation or set builder notation, that means the same thing. So let's look at an example. We have all these items. Those items should look familiar to you. If I was going to give a verbal description of those items, I would say this is the set of vowels. If I was going to give the roster of this set, I would just use the braces and list each of the items of the set with the braces on each end. Now you could also give it a name. It can have any capital letter for the name. You don't have to give it a name, but a lot of times we do give sets names. And then let's look at an example of set notation. How do we do set notation? There's a couple of variations that you could do when you're using set notation. You could use the name of the set. The set B equals the element B, and we use this straight line, and that straight line means such that B is an element of A, E, I, O, and U. So that's one way. Now, if we had a set that had a whole lot of elements, this would not be a very efficient way to write that set. So there are some shorter ways that you could use. Another alternative to that, you could also do set B, the element of B, such that B is a member of the set of vowels. So you can use the combination of the verbal description with that. You can use the combination of the roster with the set notation. But notice with the set notation, you're choosing the letter such that is a member of, that part stays the same. So it's just making a little technicality in how you write the set out when you use set notation. It adds a little formality to how you write it. Let's do another example. Let's say we have a set of integers How would you describe that set of integers? How could you describe them? Anyone? How could you describe them? Are they even?
Yeah.
Multiples of 2.
Yeah, they are multiples of 2. They are even. Do they go on forever?
Yeah.
Is there a dot, dot, dot at the end?
No.
No, so they don't go on forever. So they are restricted. What are they restricted to?
10.
10.
2 to
10.
10, right? Yeah. So if we were going to use the verbal method, we could say the set of even integers between 2 and 10. That's one way. There are other ways to describe it. That is not the only way to describe that set. You could say multiples of 2 between 2 and 10. So that's another way to verbally describe that set. If I was going to give a roster of that set, I would just give the set a name and list 2, 4, 6, 8, and 10. If I was going to use set notation, A such that A is a member of 2, 4, 6, 8, 10. That is one way. There are other ways. I could say A such that A is a member of multiples of 2 between 2 and 10. So this gives you some examples to go by and how to use these 3 methods to write your sets. Now, if our numbers did continue on forever, we would use the 3 dots, which are called ellipses, to show that it goes on forever. All right, moving on. We have the term cardinality. Man, I can't spell today. Cardinality. Can you read that? CardinA. This means that you're going to find the number of elements in a set. Equal sets. How do we determine if we have equal sets? So we have cardinality, we have equal sets. Equal sets mean you have exact same elements in the set, regardless of the order or if the elements repeat. If an element repeats, we really don't count it twice. We just count it as one element. We have equivalent sets. Equivalent sets have the same cardinality, which means they have the same number of elements. It doesn't matter whether the elements match or not. It's just how many elements do they have. When we talk about equal sets, we can say set A equals set B. So we can use this notation. Set A equals set B. We're talking about equivalent sets. We have to talk about the number. So we say the number of set A can equal the number of set B when we talk about being equivalent. When we're talking about cardinality, we say the number of set A, and we would find a value for the number in set A. So let's look at some examples. We have set A, which has the elements A, B, C, D. We have set B, which has A, D, C, E. We have set C, which has E, E, A, B, D. We have set D, which has A, C. So if I wanted to find the cardinality of set D, how many elements does set D have? What would I put for the number of elements in set D? That would be 2. if I wanted to find the cardinality of set C. How many elements does set C have? Because it has some that repeat, I don't count the ones that repeat but once. So even though the E's repeat, I would only count it once. The A's repeat, but I would only count it once. So it has how many elements? 4 different elements. Does that make sense? Do you understand when you're counting cardinality? If the elements repeat, we only count one element. So we're counting cardinality as the number of different elements. And maybe that should be included here to help distinguish that. How many different elements are in the set? So if it repeats, we still only count it once. All right, let's ask ourselves, does set A equal set B? Is that true or false? Do the elements match up? A matches to A, B matches. There is no B. So does set A equal set B? So that is false. Does set A equal set C? We have an A, we have a B, but there's no C. So that is false. Does set B equal set C? We have an A, we have a D, but there's no C. So that is false. Do we have any sets that are equal? Can you find any that are equal? It does not matter the order of the elements. It doesn't matter if they repeat, because remember, we only count that element as one. There are none that are equal, are there? All right, how about equivalent sets? That would be sets with the same number of elements. So the number of elements in set A is equal to the number of elements in set B, which is also equal to the number of elements in set C. So all 3 of those sets are equivalent sets. Now, why is C still equivalent, even though it looks like it has more elements? Why is it still equivalent?
Because you only count the repeating ones once.
Exactly. Because the elements repeated, we only counted them once. So that's why they're still equivalent. Exactly. Very good. Okay. Those terms, cardinality, equal, equivalent. You want to be able to use them when you're dealing with sets. Okay, we're going to move on. Do you need more examples or are we good? Okay. All right. Next term. Universal set. The universal set is a set that contains all the elements of a specific situation. So the universal set can change depending on the situation that we are dealing with. Usually the universal set is denoted with a capital U that is a script U. It doesn't have to be a script U. It at least is a capital U, but usually it's a script U. The term subset. So we have universal set, and now we have subset. It has elements contained in another set. The symbol used for subset is a U on its side with a line under it. Next, we have a proper set. Occasionally, you will hear this referred to as the superset. It's the same as a subset, except it cannot contain all the elements of the set. This is denoted with just the U on its side. So look at the difference. The U with the line under it is subset. The proper subset is just the U by itself. That gets confusing for some people. So you, right off the bat, you've got to study the symbols and know what goes with what. The key to this unit is knowing the definitions and knowing the symbols. So you're going to have to spend some time studying them. They're not hard, but you're just going to have to spend some time studying them because they're new to you. Okay, then the empty set. And I know you've heard of the empty set before. That just means that it contains no elements. An empty set is a member of every set. You can either use the 0 with the line through it, or you can use the empty braces. Who remembers what's another name for the empty set? It's also called the null set. Okay, let's do a few examples here. Okay, is B a subset of A? It's not. Why? It has 4. They both have 4 in it. But all the elements of B are not all in A. So it is not a subset. All the elements of B have to be in set A in order to be a subset. Not just one of the elements. It has to be all of them. True or false? C is a subset of A. True or false? That is true, right? All the elements of C are in A. So that is true. True or false? C is a proper subset of A. In other words, can a proper subset also be a regular subset? Yes, it can. All the elements of C are in A. It is not all the elements of A, so it is also a proper subset. So that is also true. All right, let's say we had set D, which was 7, 6, 5, 4. True or false? D is a proper subset of A. Again, order does not matter. We look at the actual elements. every element of D is every element of A. And because that is the one thing, if you have every element, that makes it not be a proper subset. It can be a subset, but not a proper subset. Just some technicalities with the definitions. All right, folks, let's take a break here for 10 minutes. We're about halfway through. Actually, what we have left probably won't take another hour, but we're about halfway through class time, and we've been working for a good bit of time. So let's take a break, 10 minutes, get up, stretch, get yourself something to drink, go to the restroom, whatever. But take a break, and we'll meet back at 9:02. Okay? Thank you.